Solve problem on inventory model 3A with probabilistic demand for which instantaneous demand, setup cost 0, stock levels discrete and lead time 0 by using important formulas.
Let us understand some important characteristics related to inventory model 3A. Inventory model 3 is under the category of models with price breaks as well as probabilistic demand. For model 3A, it is instantaneous demand, setup cost 0, stock level discrete and lead time 0. Now we will understand some important facts. So for this inventory model 3A, items require one time purchase only. So for a particular period of time, these items are purchased at the beginning of that period. And this model is applicable for the perishable items. For example, cut flower cosmetics. It is also applicable for the seasonal items, that is calendars and diaries. Item is ordered at the beginning of period to meet the demand in that particular period, and at the end of period two types of costs are involved. Now these types of costs are depend on the demand, that is the level of demand and level of stock. So I will write here demand and stock. It will depend on the demand and stock. So when demand is less than stock, then what will happen? So demand is less and stock is more. That means units remain unsold. And when units remain unsold, that cost we will say overstocking cost. That is because stock is more. That's why we will use here word overstocking cost. And it is notation is C1. So C1 is equal to C plus CH minus V. So C is the unit cost price, CH unit carrying cost, or we can also say holding cost, and V salvage value. So salvage value, that means the value for that unit remain unsold. Then understocking cost. So this cost is applicable when demand is more than stock. So here stock is less, and that's why we will use here word understocking cost. So not meeting the demand. So this understocking cost not meeting the demand. So here shortage is occurring. So this cost we can calculate C2 is equal to S minus C minus CH by 2 plus CS. So what is this S? S is the unit selling price minus C, that is unit cost price, minus CH by 2. So CH is the unit carrying cost or holding cost, and plus CS. So CS is the shortage cost. Then R. So next notation is R, that is the discrete demand rate with probability PR. So in question, this demand rate is shown with this probability PR, that is this probability for this demand rate is mentioned in the question under the column PR. Then IM. IM is the discrete stock level for time interval T. So for a particular time interval T, this stock level. So IM, that means we know maximum inventory. So this discrete stock level is also mentioned. And then T, that is the constant interval between orders.
Given question, a trader stocks a particular seasonal product at the beginning of season and cannot reorder. The item costs him rupees 25 and he sells it at rupees 50 each. For any item that cannot be met on demand, the trader has estimated a goodwill cost of rupees 15. Any item unsold will have a salvage value of rupees 10. Holding cost during the period is estimated to be 10% of the price. The probability of demand is mentioned in table as unit stocked and probability of demand. Determine the optimal number of items to be stocked.
Let us understand the given data. Unit cost price, that is C, is given rupees 25. Unit selling price S is given rupees 50. Shortage cost CS is rupees 15. Salvage value V is rupees 10. holding cost is 10% of price. So holding cost, that is CH, 10% of this unit cost price 25, that is 10 by 100 into 25, which is equal to rupees 2.5. So these all costs are given. Now here one table is also given for unit stock 2, 3, 4, 5, 6, and respect to these units probability of demand, that is PR, is also mentioned. Now we have to find out what is the cumulative probability of demand, and here summation of R is equal to 0 to IM PR. So we will first write the first value, that is 0.35 as it is, and because this cumulative probability, for next number we have to add these two, that is 0.35 plus 0.25, that is 0.60. Now this 0.60 plus 0.20, that is 0.80. 0.80 plus 0.15, that is 0.95. 0.95 plus 0.05, that is 1. So this is the cumulative probability. Now we will calculate the overstocking cost as well as understocking cost. So from this given data we will put the value. So overstocking cost, that is C1, is C plus CH minus V. So C is 25 plus CH 2.5 minus V, that is 10. So which is equal to rupees 17.50. Now understocking cost C2 is S minus C minus CH by 2 plus CS, that is 50 minus 25 minus 2.5 by 2 plus 15. Answer is rupees 38.75. Now we will take one ratio. So C2 divided by C1 plus C2, that is 38.75 divided by 17.5 plus 38.75, which is equal to 0.69. Now question is that we have to find out the optimum number of units. Now this ratio, that is 0.69, we have to compare with this cumulative probability. Now this 0.69 is in between 0.60 and 0.80. So I will write here 0.60 is less than 0.69 is less than 0.80. So if we compare the unit stocked, so here this number is 3 and here this number is 4. So we can say that the optimal number of units or optimal inventory level should be in between 3 and 4. So we have to take the maximum number, that is 4. So answer is 4 units.
Solve problem on inventory model 3B with probabilistic demand, for which instantaneous demand, no setup cost, stock levels continuous, lead time 0, by using important formulas. Given question: a banking company sells one of its types of cake by weight. It makes a profit of 95 paise a pound on every pound of cake sold on the day it is baked. It disposes of all cakes not sold on the day they are baked at a loss of 15 paise a pound. If demand is known to have probability density function f of r is equal to 0.03 minus 0.0003 r, find the optimum amount of cake the company should bake daily.
To solve this problem, let us understand the characteristics of the inventory model 3B. Inventory model 3 is under the category of models with price break and probabilistic demand. For model 3B, instantaneous demand, setup cost 0, stock level continuous and lead time 0. So because here the stock level is continuous instead of discrete, we have to use here the probability density function. Now cumulative probability distribution we have to show with integration of r is equal to 0 to Im f of r dr, which is equal to C2 divided by C1 plus C2. Now what is this r? R is the demand rate, Im, maximum inventory level. Now f of r dr is the probability density function for the demand rate r. and that is mentioned in the question if stock level is continuous. And on right hand side it is C2 divided by C1 plus C2. So here C2 is overstocking cost and C1 is the understocking cost. Now we will move to the given data. So C2, that is for profit, is given. Now it is given in paise, so we have to convert it into rupees, that is rupees 0.95. C1 is rupees 0.15 and that is for loss. Then f of r. So this probability density function is given in terms of demand rate r. 0.03 minus 0.0003 r. Now we will solve the question. So we will put the value of f of r in this formula. So we will take from 0 integration from 0 to Im 0.03 minus 0.0003 r dr, which is equal to C2 divided by C1 plus C2. Now we will solve this. So how to solve this? So 0.03 dr, that is 0.03 r minus 0.0003 r dr, that is r square by 2, which is equal to, on right hand side we have to put the values of C1 and C2. Now we will solve this integration. So if we observe, so we have to put here square bracket and here 0 to Im. Now first we have to put Im instead of r and then we have to put 0. So when we put 0, here whole term becomes 0. So we will write the term when we put the Im only. So 0.03 Im minus 0.0003 Im square by 2. Now minus, if we put 0, then this whole term will become 0, which is equal to, on right hand side, 0.95 divided by 1.1. Now we will simplify this. So here 0.0003 by 2, that is 0.00015 Im square. Now we will simplify this by multiplying with 10 raised to minus 5. So if we multiply here 10 raised to minus 5, then this term will become 15. So what will be the answer? So on both sides we have to multiply with 10 raised to 5. So here if I multiply 10 raised to 5, then it will become 3000 Im minus 15 Im square, which is equal to 86,360. Now we will convert the coefficient of Im square into plus 1. So how to convert? So we have to divide on both sides with minus 15. So here if I divide on both sides with minus 15, then what will happen? So here minus 15, that is only Im square. Then here 3000 divided by minus 15, that is minus 200 Im, is equal to, on right hand side this term will become minus. So if we transfer this term to the left hand side, then it will become plus 5757, which is equal to 0. Now how we can solve this? So if we observe coefficient of Im square, that is equal to 1. So we will consider A is equal to 1. Coefficient of Im, that is minus 200. So B is equal to minus 200. And this constant C, that is 5757. So how to find out the value of Im? So we have formula, that is minus B plus minus under root of B square minus 4AC divided by 2A. So according to this formula we can write minus 200, that is plus 200 plus minus under root of 200 square minus 4AC, that is 4 multiplied by 1 multiplied by 5757 divided by 2A, that is 2 into 1. If we solve this, because here plus sign and minus sign, so there are two values. So two values are, that is value of Im 165.15 or 34.85 pounds. Now this question is not applicable for the values above 100 pounds. So we have to refer, this is the answer, 34.85 pounds.
Given question, a fish stall sells a variety of fish at the rate of rupees 5 per kilogram on the day of the catch. If the stall fails to sell the catch on the same day, it pays for storage at the rate of rupees 0.30 per kilogram, and the price fetched is rupees 4.50 per kilogram on the next day. Past records show that there is an unlimited demand for fish 1 day old. The problem is to ascertain how much fish should be procured every day so that the total expected cost is minimum. It has been found from the past records that the daily demand follows an exponential distribution with f of x is equal to 0.02 e raised to minus 0.02 x, where 0 is less than or equal to x is less than or equal to infinity. This question was asked Bombay BSc Statistics 1984, BSc Applied Computer 1984.
Let us understand the given data. Unit price C is rupees 5. Storage cost, we can say that inventory holding cost or inventory carrying cost CH is equal to rupees 0.30. Salvage value V is rupees 4.50. Now we have to calculate the C1, that is the overstocking cost. So which is equal to C plus CH minus V, that is 5 plus 0.30 minus 4.50, which is equal to rupees 0.80 per kilogram. And understocking cost, that is C2, is rupees 5 per kilogram. Now probability density function is mentioned in the question. F of x is equal to 0.02 e raised to minus 0.02 x, where range is also given. 0 is less than or equal to x is less than or equal to infinity. Now we have to calculate what is the maximum inventory level, that is value of Im. So we have to put this probability density function in this formula, that is integration of r is equal to 0 to Im f of r dr, which is equal to C2 divided by C1 plus C2. So instead of r, here this function is given in terms of x. So we will put the value. So integration of 0 to Im 0.02 e raised to minus 0.02 x, which is equal to C2, that is 5 divided by 5 plus 0.80. Now we will solve this. So this is the function of e. So e raised to minus a. So how to solve this integration? So e raised to minus ax divided by minus a, because coefficient of x we have to take in the denominator. So 0.02 terms is constant, so we have to take outside the bracket. So for this integration, e raised to minus 0.02 x divided by minus 0.02, and range is from 0 to Im. And on right hand side it is 0.862. Now we will solve this. So instead of x we have to put Im, and again take minus, and instead of x we have to put 0. So how to solve this? So for that, denominator minus 0.02 we have to take outside the bracket. So it will become minus 1. So here we will give minus sign, and inside the bracket e raised to minus 0.02 Im minus e raised to minus 0.02 into 0. That is, this whole term will become 0. So it will become e raised to 0. So we know that e raised to 0 or anything raised to 0, that is 1. So which is equal to 0.862. So again we will solve this. E raised to minus 0.02 Im minus 1 and on right hand side 0.862. Now we will multiply this minus sign with inside the bracket. So it will become minus e raised to minus 0.02 Im plus 1 is equal to 0.862. Now this plus 1 we will transfer to the right hand side. So it will become 0.862 minus 1. So when we calculate this, we will get the answer minus 0.138. Now we have to solve this. So here minus minus on both sides is getting cancelled. So I will cancel here. Now how to solve this? So with the help of calculator, if we observe, ln function is there and inverse of ln is e raised to x. So if I take both side ln, so here this ln term and this is also ln term. So this ln and e E term is getting cancelled, and if I take ln of 0.138, so I will take here ln of 0.138, that is equal to minus 1.98, and on right hand side this ln and e term is getting cancelled, and here only minus 0.02 im. So how to calculate im? This minus is also getting cancelled, so 1.98 divided by 0.02, so which is equal to 99. So I will take here, therefore im is equal to 99. So this is the answer.